Take it up.
Hello, everyone. We'll start with the disclaimer. I'll flash it for a couple of few seconds. In recent years, with increasing popularity of modern cloud platforms and increasing adoption of microservices-based architecture, there has been a paradigm shift in the way we monitor our services and systems. With private, public, and hybrid clouds and the modern distributed infrastructure or the distributed services and its inherent complexities, there has been the approach to monitor these services has changed significantly. There are many unknown breakpoints, and when breakdown happens in the production, it would be like finding a needle in the haystack to identify or pinpoint or to reach the root cause of the actual issue. Here today, in this session, we will cover how VMware IT embraced or adopted observability and use Aria Operations as the observability platform. Aria Operations for applications as the observability platform. We all know about observability. We know all about monitoring. So what is observability? So observability and monitoring are two related but distinct concepts in the context of monitoring systems or applications or in case of service operations. Let's try to differentiate both. Monitoring is a process of collecting data or metrics from remote systems to track its health, performance, or availability. Observability, on the other hand, is a more holistic and comprehensive approach. It refers to the system's ability to report its insights in internal state and behavior even when things are not functioning properly or as expected. It is more of an outside-in approach compared to the monitoring approach of how we get the data out. So, in a nutshell, observability provides answers to why something is wrong and thereby helps address those challenges and fix it and reduce the MTTR. How does observability does this? How do we achieve this? For this, let's come to the three pillars of observability: the metrics, traces, and logs. We are familiar with metrics and logs, but traces is a relatively a newcomer in this space. So what is a trace? Trace is the entire operation or the set of operations that happen within a distributed system. It collects minute details, something that we call as spans, and that is reported to the reporting server or the observability platform. So this is the tool that we are talking about, VMware Aria Operations for applications. It's a high-scale analytical platform which can accept the three pillars of observability, which are traces, metrics, and logs. And this helps in monitoring or observing the systems that are distributed across multi-clouds or multiple data centers. VMware Aria Operations for applications provide end-to-end visibility or observability for infrastructure components like network, host, ESXi servers, or containers, and application components like transactions, containers, or databases, middlewares, web servers. So that extent, it can provide the end-to-end observability. We'll see the general architecture, a very high-level architecture that we have employed at our place. So our workloads run in multiple public clouds, private cloud, and on data centers. So we use a proxy to route all the traces, metrics, and logs to area operations for applications. And it supports the direct ingestion as well. But using a proxy is always advantageous because it helps in doing filtering and sampling and other, connection-oriented services. It does batching and helps in effective utilization of the bandwidth as well. VMware Aria Operations for Applications provides in-depth insights to various personas like application owners, site reliability engineers, or business owners. It provides it has the built-in dashboards, or you can build custom dashboard to suit your requirements and have a single pane of visibility for your service or applications. It can alert if any anomaly happens in the systems so that the stakeholders are notified, and it does something like a proactive. Before the system is going to crash or end into issues, it can proactively notify based on complex AML notions. So in our SaaS transformation journey, when it comes to observability and monitoring, we had few requirements. The back office and front office operations are equally critical, and we need to trace the transactions right from the origin or the user interaction all the way to the backend, traversing through the core components that it goes through in. And as the systems grow complex, finding the breakpoint is very critical, right? So it generally takes more time, and we need to reduce that time, or the MTTI, to as small as possible. The user phrasing or the origin of the request. So seamless troubleshooting is the need of the hour. We cannot spend hours on fixing, which is a very mission critical system. So that was another requirement. And observability can provide in-depth, apart from the operation side, data insights. It can be user behavior. It can be like revenue trends. It can be like product usage. So another core requirement was to capture these business insights from the system. Okay, so these were our core considerations when we were going with the observability. Yeah, and we faced few challenges, right? So with the existing setup, it was monitored, different components were monitored by different systems, okay? So it's all siloed. There is no scope of correlation, limited visibility because, to a certain extent, let's say load balancer, it's monitored by a specific tool. Or let's say a set of, core infra services, another tool. So end-to-end visibility was very limited. So that was another challenge. And so distributed troubleshooting, as I said, it's all related, no correlation. And as we involved multiple tools, there is high learning curve as well, right? So the team need to know about how to use and manage those tools. So these were the challenges before we embarked on the observability journey. So for implementation, again, the 3 pillars. For metrics, we are using Telegraph. And for the Kubernetes platform related, we are using Kubernetes operators for it. For the cloud providers, we are using APIs to pull in scrap in the metrics. And it supports push metrics as well, right? And for traces, we have our own Wavefront SDKs or instrumentations. And where it fits best, we are using OpenTelemetry, Zipkin, or Aegir. So it's all supported from the tracing point of view. For logs, we are using FluentD or FluentBit to push logs to the system. So integrations. Aria Operations for Applications by default supports more than 250 integrations out of the box. This is a very comprehensive, not comprehensive, it's a basic list of what it supports as of now. The full list is in the link provided. And it is a generic integration approach as well. So you can push, it can collect, if you use some Telegraph agent or something, you can pull the metrics. or it is capable of receiving from the third-party sender. Okay, we'll see more about in the next those slides. So we will see, so the data is now in. Now what we can do with the data? How can we visualize it? And how can we get alerted when some anomalies are happening? So I will request Satya to cover that.
Yeah, hi. Thank you, Magin, for handing off. Which one, green, right? Next. So when it comes to the operations dashboard, we have this centralized operation dashboard for operations related, where we can see the application metrics with respect to the which application is having what kind of issues with respect to metrics, errors, and duration, which is red metrics we call it as, which is nothing but coming to the requests, red metrics, request for seconds, how many number of requests which we receive for within seconds. And the second one is errors, how many errors which we received for the specific applications with the span of time. And the third one is the duration. Duration is nothing but how long the trace took the time of the duration, whether it's at 5 seconds or 10 seconds, like that. And coming to this application monitoring, we have this several filters over here. You can see this application dashboard, application filter. Here you have to, it's a kind of an interactive dashboard where you have to choose the application and following with the specific service and the operations and the span kind. If you have any specific HTTP status codes, if you want to check for 400 errors or 500 errors, and if any cluster things and shared services or direct services, and which kind of sources it was, whether it is a summarized view or just direct view, you can select the filters and get this complete list of view. And this the last one is coming to historical data, which is integrated with AI and ML concept, which will give you the complete list of requests in a historical view. Here is a link which will provide you you can share this link to the external ones, where you no need to log in to view this complete dashboard in operational perspective. And again, this is a kind of a same dashboard, which is for with respect to the service. Again, you have the same filters over here. And coming to here, this service, you need to select specific service to get the matrix of red matrix, which service is having causing issues within a span of time. And here is a top 5 list for total number of requests, for which request is consuming the service, top 5 services. And this is for top 5 errors. And this is for the shortest duration for top 5. And the same way here you can see the component matrix and historical view. And the same way you can give the link for operations or other teams to view this complete dashboard for a troubleshooting purpose. The next is the custom dashboard. So custom dashboards is nothing but you can create your own dashboards with respect to the network or latency or a data center view or file systems or virtualization or anything, TKG, Kubernetes, memory usage, request rate, pods, restart rates, and everything. Yeah. And here you can see this one with the geographical top 5 response times.
Yeah, just to add to it, this is a custom dashboard, and this can be easily built with the custom dashboard builder. So you can choose the data points and create widgets or graphs from it. And so it supports a lot of widgets which are built in. Just need to select it and select the data point, so it will populate. And it is, if you see, this is from a NS1 monitoring integration that we have. And this is a proxy, layer 1 proxy. So based on the need, so this is from the TKG environment. So you can create your own dashboard, which is highly customizable to your needs. Okay, so this is the custom dashboards. So you can also, the metrics of your interest can be used in creating these dashboards.
Yeah, and this is for tracing, browser tracing metrics, where you can see the trace of your application with a specific trace. This is, for example, if you take this trace, this is a service level map, and this is what the red matrix for the request, errors, and rates. And here you can see the trace details. And you can export the traces, and you can share the link, and you can expand this each individual widget in a maximized view, and you can able to see everything.
Yeah. So you just, you can filter it using the operation of the trace ID.
Trace ID.
And once you narrow down to the trace of your interest, which you want to investigate what happened, you can go to that using these filters. And once you select that, it will show you the entire, the way the trace was propagating, right? So in this case, we see that there are 3 services that were involved. And if you click on it, it will show you each of the spans with the duration and the state of it, right? So it gives much more in-depth trace analysis here. So this is the traces browser.
Yeah, in next slide, you can see this specific trace for this specific printing service, where it give you the printing number of total of requests, and this related to the completely into a red matrix. And you can see the graph of calls between the services, and you can same way you can maximize and you can utilize this in a bigger view. Comes to this is the one where we have this spanning which trace is consuming the more response time within less time, where it causes the errors. And click the span. Yeah, this is what which one is taking more time. Yeah, coming to alerting, we have smart alerts and dynamically filtered noise. We have so many alerts we can configure based on our requirements to capture the anomalies. And we have multiple targets for integrations for ticketing tools, mail notifications, Slack, and identify the related firing alerts. And we can organize the related tags, alerts with the tags. This is a sample alert configuration for a latency of alert. So this is what the query, which you can able to see here. And when it reaches this threshold, it will trigger an alert to these affected services. And this is what the mail notification, which will go to the target.
Just to add, so Wavefront has, I get interchangeably with Wavefront. That was the prior name to this tool. So it has a query language called WQL, which is Wavefront query language. Very powerful query language, which you can use in creating your dashboards or charts, or even which can be used for defining your alert definitions. So in this case, this is a very simple query, which says mean max of this particular matrix, or on this on this tag, which is, if it is more than 160, it's a one condition, right? But this is kind of, as of now, it seems like it's a very static alert definition, but it can be dynamic as well. It can look into the historical trend and use dynamic thresholds. Okay, so that feature is also present in there.
So yeah, next out, this outcomes.
Okay, so so it's evolving, and we are in this amazing journey of implementing end-to-end observability. So far what we have seen is now, instead of having a dispersed system, we have a common centralized observability platform, and we are still in this journey. So as and when our systems get more observable, we are adding to the stack. Okay. So with that, now in single pane or using intelligent alerting, we can actually get to the root cause and pinpoint, okay, this section or this component is what exactly is causing the issue. Okay, this can be using a visual cue from the dashboard, or using smart alerting rules, we can get to it. And now we have, scope of correlation. Visualizations are better. It's in one single pane, as we decide. And other thing is, this is what what was our biggest advantages that we received. It is when it comes to distributed microservices, now we have a visual path of how the transactions are going in, and we have visual cues where there is potential bottlenecks or breakages that can happen. And we have done many optimizations just seeing the detail of the span level. Okay, this particular span is taking more time than it is expected to, right? So earlier we had the end-to-end, now we have span level breakdown of what do you call response times, right? So we did a lot of optimizations with it, and other thing is it is a SaaS solution, so there is no management overhead. All you have to, if you have an on-prem data center, all you need to have is few proxies and configure it to send. Yeah, so that's it for the presentation. I request you to take the survey. Yeah,
Thank you.
thank you.